Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk on computational chemistry. You know, nowadays computational chemistry play a very important role in chemistry. So learning of computational chemistry is important in modern world. So let us start learning of computational chemistry. My friends, computational chemistry uses results of theoretical chemistry. What does it mean? You know theoretical chemistry, you are applying through the software. Incorporated into efficient computer programs to calculate structure and properties of molecules. So quantum chemistry is behind the computational chemistry. It calculates the properties of molecule such as structure. What is the structure of your molecule or new molecules? Relative energy, charge distribution, dipole moment, vibrational frequency, reactivity, and other spectroscopic quantity. Now you understand how computational chemistry help you, like properties, structure, relative energy, charge distribution, dipole moment, vibrational frequency, reactivity, and other spectroscopic quantity. You know UV visibles, IR, NMR, ESR, all spectroscopic technique is very helpful through the computational chemistry. So you have the dual characterization. You have IR from your theory and you have IR from the instruments. And then you can compare your results, either UV visibles, either IR, either NMR, and the properties like dipole moment, and compare with the instrumental results. My friends, computational chemistry range from highly accurate ab initio, from starting ab initio method, to less accurate semi-empirical, to very approximate molecular mechanics. What does it mean? Means theory and experiments, whatever you are getting spectroscopic results and their values, it will be not exactly match, but it is near to, very approximate, if you are using proper commands and proper theory for the calculations. Now friend, advantage of computational chemistry. It allows the medicinal chemist for use the computational power of computer for measurements of what measurement you will do by using this computational chemistry. Molecular geometry, electron density, electrostatic potential, conformational analysis, different types of energy. Very important, because people are always have their questions, what is doing computational chemistry? Why you are focusing on today on computational chemistry? So what is the utilizations? So you can look at here. Molecular geometry. You can optimize the molecular geometry, then you have to do the calculation like electron density, electrostatic potential, conformational analysis, and different types of energy. The second, determination of a structure of ligand and target through X-ray crystallography and NMR spectroscopy. Third, docking of ligands in receptor active sites. You know, docking is also a method of calculations. Docking of ligands in receptor active sites, an exact measurement of geometric and energetic favorability of such interactions. My friend, comparison of various ligands through various parameters. Then you can do your experiment after getting a lot of results, choose best results, and then you have to do your synthesis in your lab. What does computational chemistry calculate? What we are talking right now. Energy, structure, and properties. What is the energy for a given geometry? How does energy vary when geometry changes? Which geometries are stable? And how do atoms rearranges to form a new molecules? And how do structure, energy, and properties change over time? So, examples, you can calculate the ionization energy, HOMO energy, electron affinity, LOMO energy, proton affinity, electronic excitation energy, UV visible spectra, NMR chemical shift and coupling constants, reaction path and barrier height and reactions rate. A lot of things you can calculate with the help of computational chemistry software. Now, molecular modeling, the three-dimensional shape of both ligands and target site may be determined by X-ray crystallography or computational method. The most common computational methods are based on either molecular or quantum mechanics. My friend, both these approaches produce equation for total energy of the structure. So computational methods, there are two main types method depending on the starting point theory. First, classical methods and then quantum chemistry method. What does it mean? Classical method are those methods as neutron mechanics to model molecular system. And quantum chemistry method, which makes a use of quantum mechanics to model the molecular system, and this method use different types of approximation to solve Schrödinger equation. So classical methods, you have molecular mechanics, molecular dynamics. Quantum mechanics method, you have semi-empirical methods, ab initio methods, and density function theory, DFT. Now it is very clear to you what is the meaning of classical methods and quantum mechanics methods. The molecular mechanics and molecular dynamics belongs to classical methods, and semi-empirical methods, ab initio methods, density function theory belongs to quantum mechanics method. Now computational chemistry, you know, the quantum mechanics, look at here, molecular mechanics, MM, hybrid quantum mechanics and molecular mechanics, and semi-empirical. Now look at how molecular mechanics working. Bond length, bond angle, dihedral angles, and many more parameters needed. Then you can see the quantum mechanics. Now semi-empirical formula, empirical methods. Now I am going to some light on molecular mechanics. Molecular mechanics program use equations based on classical physics to calculate force field. Force field is also very important parameter. Atoms treat as spheres. Keep in mind that is very important for the beginner. Atoms treated as a sphere, bonds as springs, and electrons are ignored. Just remember this point. Atoms treated as a sphere, bonds as springs, and electrons are ignored. It is assumed that the total potential energy of molecule is given by the sum of all energies of attractive and repulsive forces between atoms in a structure. What does it mean, total energy? So the molecular mechanics equations like EB, EA, ED and NB then after combinations of energy you will get the total energy. So what does it mean? It means EB indicate the energy involved in the deformations bond either by stretching or compression. EA means the energy involved in the angle bending, and ED the torsional angle energy, and ENB the energy involved in the interactions. So torsions, bond stretching, angle bending and non-bonded interaction. So total 4 interactions we have. After calculation of these 4 interactions means we are calculating the total energy. My friends, what is the meaning of force field? This is a term. Force field refer to calculations of the interactions and energies between different atoms, between bond, in stretching, angles bending, torsional angle and non-bonded interactions. I hope this term is clear to you. Force field ignores the electronic distribution. Very important. You have to write it down. Force field ignores the electronic distribution while quantum mechanics consider electronic distribution of molecule. So classical empirical force field, AMBER, assisted model building and energy refinements. CRAM, chemistry at Harvard, macromolecular mechanics. NCVFF, consistent valence force field. These are the empirical force field for calculations of force field. Molecular model using molecular mechanics. The molecular model are created by either using an existing commercial force field computer program or assembling a model from a structure fragment held in the database of molecular modeling program. Now, what does it mean? Go to step by step. Step 1. The selection of the structure fragment from database of the inside in programs. The model with the relevant functional groups and or structure is selected. You can make select or make the models in your software. You draw the structure. The inside second model of this structure, and then the fragments are linked together. Fragments are joined to each other by removing hydrogen atom. You can see at the point at which the fragments are to be linked, the bonding state of each atom is checked and it necessarily adjusted. And finally, the force field of the model is minimized to give the final structure. So it depends on you. Nowadays, everything we are doing with the help of software. You can draw the molecules, optimize it. Molecular dynamics is a molecular mechanics program designed to mimic the movement of atom within a molecule. Molecular dynamics can be carried out a molecule to generate different conformations which on energy minimizations give a range of stable conformations. Alternatively, bonds can be rotated in a stepwise process to generate different conformation. Molecular dynamics can also be used to find minimum energy structure and the conformational analysis. This is very basic chemistry. You can see the energy versus time graph and you have the butane structure. So you can see the degree of rotations. You are getting different conformations. You have the staggered, you have eclipse, you have a skew or gauche, like that. And then look at the energy. Eclipse is more energy, and then you compare your results with the energy versus time graphs. Now quantum mechanics. My friends, quantum mechanics is based on arrangement of electrons of molecule and interaction of those electrons with electron nuclei of other molecule. It based on the realization that electron and all material exhibit wave-like properties. The quantum mechanics based on finding solution to Schrödinger wave equation. You know, my friends, Schrödinger equations is very basic quantum chemistry. The Schrödinger equation is the basis of quantum mechanics and gives a complete description of the electronic structure of a molecule. If the equation could be fully solved, all information of a molecule could be determined. SI is equal to E psi. You know, H Hamiltonian operator, psi wave functions, and E energy system. To solve Schrödinger equation was found too difficult. Hydrogen total energy of hydrogens can be described as the sum of kinetic energy and potential energy of its two components, that is proton and electron. So Schrödinger equation for this relationship can retain SI is equal to K plus V is equal to E psi, where K kinetic energy and V potential energy. You know, my friend, describe both the wave and particle behavior of electrons. The wave function is described by psi while the particle behavior is represented by E. In system with more than one electron, the wave function is dependent on the position of the atom, and this makes it important to have an accurate geometric description of a system. So my friends, quantum mechanics methods, as you have already seen, ab initio method, semi-empirical methods, and density function theory. What is ab initio method? Ab initio translated from Latin means from first principle. This refers to the fact that no experimental data is used and computations are based on quantum mechanics. It derived directly from the theoretical principle. So different level of ab initio calculations, Hartree-Fock, HF, and density function theory. So what is Hartree-Fock, HF? The simplest ab initio calculation. It based on central field approximation. The major disadvantage of Hartree-Fock calculation is that electron correlation is not taken into consideration. This is very important point. Electron correlation is not taken into consideration. So density function theory, you know, my friend, considered an ab initio method but different from other ab initio method because the wave function is not used to describe the molecules. Density function theory, in which total energy is expressed in terms of total electron density, is used. So DFT is focusing on the electron density. So density function theory method take less computational time than Hartree-Fock calculation and are considered more accurate. So semi-empirical method, my friends, semi-empirical quantum methods represent a middle road between the mostly qualitative results available from the molecular mechanics and high computational demanding quantitative results from ab initio methods. Semi-empirical method use experimental data to parameterize equations. Like the ab initio methods, a Hamiltonian and wave functions are used, less accurate than ab initio method but also much faster and capable of the calculate transition state in excited state. So choice of methods. The method of calculation based on what calculation need to do or to done and size of molecules. Because this is the computational chemistry, it depends on your choice and it depends on the structure of molecules. So molecular mechanics useful for energy minimization, identifying a stable conformation, energy calculation for specific conformations, studying molecular motion and studying different conformation. So my friend, quantum mechanics method are suitable for calculating molecular orbital energies, heat formation for specific conformations, dipole moment, bond dissociation energy and transition state geometries and energy. So computational cost versus accuracy. Everything depends on economics. So look at here, molecular mechanics, quantum mechanical methods, atom and small molecules, large compounds and nanocluster, proteins, DNA and RNA. So number of atoms when increases, then you can see the accuracy is not working properly. So quantum mechanics versus molecular mechanics. What is the difference? Quantum mechanics correctly describe the bond breaking and bond forming. Applications limited to 100 of atoms. Molecular mechanics does not properly describe the bond breaking and bond forming, can treat more than 10,000 atoms. So quantum mechanics and molecular mechanics. Quantum mechanics more expensive, more time, more computing power, used for small molecule. It can calculate electronic properties like electron density. Application limited to 100 of atoms. In molecular mechanics, you have the less expensive, less time, less computing power, used for large molecules. It cannot calculate the electronic properties like electron density, applicable to more than 10,000 of atoms. So energy minimizations. My friends, stability and energy has two different corners, two different directions. So focus on the energy minimization and stability. Energy minimization produces the nearest stable conformation to the structure presented and not necessarily the global conformation. Energy minimization involves alterations of bond length, bond angle, torsion angles and non-bonded interaction. So look at here in graphical or pictorial picture, E total for different values of parameters of model structure. So you have change in parameter. First starting conformation, then change in total energy, then local minima energy value for E total, then you can see the Y, and then the global minima energy value for E total. So you have the two minimum energy here, a local minima and global minima. Global minima is more stable than local minima. Now molecular mechanics energy minimizations. Molecular mechanics is an approach of energy minimization and find a stable low energy conformation by changing the geometry of a structure. My friend, types of algorithm, steepest descent procedure, conjugate gradient procedure, Newton-Raphson procedures. This is complete software drum. Selection of energy minimization algorithms. The selection of energy minimization algorithm depends on size of system and current state of optimization. When molecules having larger than 200 atoms, then conjugate gradient procedures When molecules having less than 200 atoms, then Newton-Raphson procedure. When molecules having larger than 10 kilocalorie mole, then steepest descent method. So computer graphics also very important. In molecular modeling, data produced are converted as visual image on a computer. Image displayed as a space field model, ball and stick model, CPK model, mesh model and ribbon model. I repeat, a space field model, ball and stick model, CPK model, mesh model and ribbon model. So look at here, for example, stick model, then ball and stick model, CPK model, and you can see the spring, you can see the ribbon representation of dihydrofolate reductase. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.